Good afternoon, everybody. My name is Paul Ehret, working currently for Felix Construction. Some of you were ex-colleague of mine. Thank you. I will talk today. I was trained as an architect, and I will try to talk from a facade construction company point of view. Talking about systemic design to production. When I used to teach or when I used to train people, I was always mentioning or trying to advise people how it's not just about modeling a 3D model, but also how to handle all the information. You need to actually push your model all the way to production and life management and all the other things that a lot of you have already experienced, I guess. So this is not my office view, but I heard this morning talking about stress at work, and I could say that my office is trying to lower the stress at work by being at 5 minutes from the Le Mans Lake, which having a lunch break over there, I guarantee you, gets your blood pressure pretty low. I will do a quick introduction about Felix. I am not from the sales department, but I'm more from the technical department. But still, I hope I can just quickly explain you what kind of scale of company. So we were, in 1935, we started as a local locksmith, and all the way during the 20th century, we've been winning bigger projects, like the UN project in Geneva in '71. The project I've been hired for last year is another United Nations project. So we built a building from Nestlé in Barcelona. We then won the Manchester airport, which made that we opened office in London. We delivered the HDM Tate Modern gallery, the upper part. We built the facade. And then we also opened an office in Madrid in 2008. We actually bought an ex-subsidiary from Perma that was, going through crisis, I think, in 2008. So now we have another office also in Madrid. We are not a huge company. We're, I guess, a little bit of a middle-sized one. And you can see how the different people are distributed. There's, of course, the biggest chunk of people are working within the factory. And So this is really important. Our office, apart from being not too far from the Le Mans Lake, has the design part, the R&D department here, and all of this is in the factory. There's a small connector between the two spots that make it really important that whatever we design, you can go to see in the production line how it looks like. So this kind of feedback loop or iterative work is, I think, really important with any kind of custom or semi-custom facade work you're trying to do. I think all of the people working in this, being here, work on mass customization, like Christiana was saying. So we know how many times we have to go through, iterate through panels, through space, to ensure that what we actually delivered will be possible to build or more economic. Some of our values, and always trying to go for innovation and creativity. I remember my boss telling me that 10 years ago, we used to invite the architects in our office down to Switzerland, spend an entire week there, go back and forth between them and our design teams to iterate and ensure that the details we would actually draw and build, that would be the exact ones they would like to have. Look on the facade. Numbers. So we used to be mainly Swiss implemented, but you can see that the UK market in salmon got much bigger, I think. Curiously enough, since the Brexit, I haven't seen that many cranes in London. So I think this market's still hopefully growing for us and for everybody here. And yeah, we're starting to build in France and also in Luxembourg. These are our London projects. So as you can see, there's nothing like you guys design at Zaha or you in studio. It's all flat, quadrangular, boring panels. But I guess it's a little more what's behind all of these panels, highly performative components. The project I'm working on now is a closed cavity facade for the UN project. So yeah, finally getting into more of my presentation, what I can talk a little better than doing an overall of Felix. So a small introduction, which I already started. Then talk about how can we do a semi-automated workflow integrating the project's variables. Talking about data, how do we deal with all the different layers or all the different kind of data that we are getting in and that we are actually then giving out to the next online. Talking about deliverables. What do I have to give to the factories for the thing to actually happen? Talk briefly about cloud and project management. I think Michael did a pretty clear and a large overview about all of this. And then yeah, hopefully do a little conclusion. So yeah, again, I think Felix market, we're not a huge company, we're a middle company, and our money maker are custom, semi-custom facades. I say semi-custom because unlike what you've been seeing before, where people at Zaha or you in studio, there's a lot of these facades that have every single component that's actually different than the one next to it. We always want to say, okay, let's try to rationalize it a little bit, but having worked on this kind of facade, obviously there's a lot of difference. While us as Felix, on 1,600 panels, you would have, I guess, 1,400 that are from 3 different families, and then the last 200 would be very, very different. So that's why I always talk about semi-custom components. And I think whenever you bring customization somewhere in the production line, that brings a need for an iterative work to ensure that what you actually deliver is buildable. So the more you do custom stuff, the more time it takes for you to just get it done properly on every single step of the production line and also the digital chain, obviously. So hence, need for workflow. This is the profile matrix. That's every project at Felix starts with this. There's this guy who's been designing profiles for 40 years. We don't reuse catalog profiles. Every single project has custom profiles. So maybe we start with 100 of them and then we obviously try to reduce them to about 50, like on this project. So now from the point of view of one profile, as I said before, I'm not going to talk about really sexy models. I think we've been seeing quite tremendous geometry in the past presentations. But I think the biggest complexity in my work was not to model profiles, make holes, and do intricate work, even though if it's, you need to have a little bit of a knowledge to model this properly in a way that it actually gets together at the end. But I think it's more about the data management. When you talk about one of these profiles, when it's designed, it has a name. When it's ordered, it has another name. So basically, when it goes from one department to another, it changes the name. And in its name, there's a little bit of a memory of all the information around it that you need to actually handle your order and fabrication properly. So it looks like it doesn't make any sense from here, but all of these guys, all of these departments have different needs. So that's where I think the need for project life cycle management makes a little bit of sense. If you have to administrate all of this by hand, it's a nightmare, especially because they used to do for each piece one drawing and then one drawing in the assembly that again has a different name. So you can see the nightmare when you deal with project metrics, that the one I'm having now on the UN project, we have about 160 different assemblies and more than 2,000 different parts. So you want to get a bit of automation there. So that's what we usually get from architects. You have clean elevations with different panel types that are identified if the work has been done properly in the beginning. Different heights, different quality of these panels that then you want to integrate that in kind of like intelligent model with conventions of vertical, horizontals. Every facade is usually done out of vertical and horizontal cladding. If it's 90-degree ones, then every single of these panels is a little bit of a placeholder for all the metadata that you're actually going to need to pass on the information of this panel to the next stakeholder, which are of course quantitative data, which is the length, height, eventually angles of your panel. But then also the zone, the subzone, where the panel sits, what kind of a glass, if it's left or right opening panel, etc., etc. So the earlier you get all of this information out of these setting out drawings that are the ones that are being approved by the architects, once you have this, then you have these abstract panels, that I call them, which already have all of the information to be passed on downstream through different quality controls. Then you go through LOD, 300 R&D department, watches over it, and then before it goes to production, we have the production department that also has to go through it. So at every single step, we are getting more data, we're getting more complexity, we're getting more detail. There's a huge effort for quality control, because so far a lot of stuff is still done by hand, but the idea to kind of get rid of all of this in the middle and to try to have a database that's linked directly to a setting or drawing that is also linked to a catalog components that will generate all these namings, all the assemblies and sub-assemblies for the construction quasi-automatically. So for this, we're initiating a collaboration with a school in Switzerland called ETH, because what we have now, we call this the Constellation. It's not a constellation of software. Obviously, some people use different softwares, but we are trying to gather everybody around the same kind of information. So there's different colors, there are different kind of lines. So my work is try to ensure that even though if there's a lot of 3D information we're already delivering, especially to production, is that we can have not dotted lines. That means that we can move more and more automated stuff with less quality control in the middle. So some of it will be mainly to have this live catalog that whenever the project changes, you want to ensure that the sales department knows how many mullions of which type they have to order, when they have to have it, etc., etc. So this is the part that we're initiating now with ETH. That actually, basically what you see here, that's still on the last project, we created all of these numbers by hand, which means every time you have a different object, every time you have a different mullion, you have another number. If this mullion is part of a sub-assembly, that then will change, also this sub-assembly changes number, etc., etc. So all of this now, we're trying to generate it automatically with a set of variables that these mullions depend on. Then you have the combined variables of these components within assemblies, and then the nomenclature of each element or panel automatically generated. Sorry, it's a little abstract, but trying now to talk more about, modeling techniques. I think it's nothing new. A lot of you guys have been dealing with parametrics, associativity, etc., etc. So I've been trying to summarize the way we model stuff in, that's the parametric wireframe underlying associative geometry. And these are obviously the 2D profile that we saw in the beginning. But then I try to differentiate elastic elements like mullions, joints, and glass, because they depend on the geometry of the final panel, and the punctual or the local pieces that are actually the connectors that don't change in geometry, like the hooks, guides, and all of these guys, they're rationalized pieces. You don't want to have a ton of them, so that's why I call them punctual pieces. They don't depend on the panel size. They're always the same. Trying to talk about genealogy of modeling, we always want to ensure that what we model, we can reuse it. So that's why I talk about genealogy in the way that from a standard panel that still might have a lot of detailing changing as we're getting in the project, but in parallel, we still need to study, for example, these corner panels that are more custom than others. But if you change something in this model, you want to ensure that it also is affecting the entire rest of the model. So it's a little bit like nested modeling of panels, where you reuse parts of some of them in the most complex ones. So there's the small panel, the bigger panel. It's doing some genealogy there. I'm trying to be quicker. You guys know how to do that. Tree structure, which is, in French we call it arborescence, which basically is the essence of the tree, where I think that's a little bit what CATIA takes above a lot of other solutions, that the way you aggregate data, people did PhDs about tree structure for Airbus or Boeing, as we saw with Cristiano this morning. There's so many different ways to actually aggregate this data, and that's only with a little bit of experience, and if you know what you're doing, that you can be really efficient in the way you aggregate it. So that's why one of the first things we initiated when I arrived in Felix was to try to make sense about every single component name, that when you read a number, it's not like, oh, 1, 2, 3, 4, whatever. It's that the sequence of the numbers, we always have each component is made of 5 digits, that you can actually know where it is from, the typology of the object, and through these little charts. So that's really, really important. Also to generate automatically all of the panel names and numbers. So this is a little bit this tree structure that you can see through the interface of 3DX with the actual icons of what it is. So this is one element that's subdivided into the screen part of it. Then you have the skeleton, and then you have the part of the skeleton that actually opens. And then the last part is called the allège, le panneau, which is where there's actually all the motor and everything for the panel to open, the shaders, sorry, to open or close. And then in each of these, you have all of these elastic parts or punctual parts. You can see much bigger now. Okay. Deliverables, really important. Again, summarizing a little bit, trying to set up this adaptive or smart component, that a standard panel that has its inputs, geometrical ones as qualitative ones. You want to ensure that you always give the same thing to the factory so they know what to do without giving you a phone call every 5 minutes. So you need to have a complete axon of every single component so people can know what to assemble where. A clear specification nomenclature file where all the 100 or 150 objects are mentioned. One piece needs to have a little bit of a milling 2D drawing. I'll explain it why after. A 3D model of it. And same thing for the folding, for the metal sheet parts. So why do we still need 2D? Well, that's because when one of these profiles arrive in the milling part of the factory, the guy arrives, sees the profile, he can read, he can see what is the geometry of the profile, but then some of them are bigger than others, so he wants to ensure to measure the size of it so he knows which one he has in his hands before they were labeling all of these with thousands and thousands of measures. Now we got rid of it because the machine recognized directly with the geometry what it is. It's modeled in 3D. But still you need to have a little bit of this 2D piece of paper that the guy, okay, I know what I'm doing. So Axon with the, yeah, all of these has unique names. The final name for production of each object. As I was saying before, this is the metric of the project. 160 different types for 1,600 panels. And each of them, then you need to have, I don't know, yeah, there's like more than 150 objects per panel. These are assembly drawings. On the production line, the guys that are putting all of these 150 objects together need to know what goes where. So there, we haven't been able to get rid of AutoCAD. CATIA is not the best for 2D drawing. It hasn't been designed to produce 2D drawings. You can get your way around it, but yeah, AutoCAD still there. Hopefully we can move that to 3D soon. And yeah, project management, coordination, a little bit of what we saw before, this vision of collaborating on the same platform. People have different use. People need to have just a little bit of window, what's going on. Some people need to interact with the model a little more in different places on the planet. This is what everybody sees. Again, I'm not going to talk more about that. We've seen that before. And yeah, that's the kind of thing I want to ensure now, maybe next project that the guys on the production line, they can actually click on an object and know which number, which object it is, so we don't need to do the 2D AutoCAD drawing anymore. And we can explode these axons following the different tree structure. And yeah, coordination, we're also hopefully soon going to sell coordination services, even though if the GC is responsible for it, we realize that we are doing it much better than them. So next project, we'll try to sell that to the client, at least for the facade part. So yeah, quick conclusion, to quote a little bit what Gehry was saying. He was talking about, I think I did not mention BIM during this presentation. Gehry was talking about paperless project delivery, which means basically, yeah, you just take your paper, save the trees with it, but deliver it differently. So what you need is obviously have a proper workflow. The difficulty is that you need to have a workflow that's robust enough that enables you to handle one project with it, and that everybody knows, every stakeholder know how to actually cope with it. But it also need to be adaptive enough to cope with the different project variables. Not every project is the same. Architect likes to design different facades, obviously, that's the signature. So that's a little bit of a tricky thing. Do something robust, but flexible at the same time. CDE, common data environment. I think more than saying, oh, we all work in 3D, I think it's more about saying we all work on the same interface. We all use the same mean and matters to actually solve our problems. That actually also quite is a big step up. And yeah, try to make sense of the nomenclature of the objects we're dealing with as a construction company. So yeah, I think I'm done with the presentation. I am having next Friday, that was just a pilot project. I've been in Felix now since a year. Next Friday I have the same presentation in front of the board of directors of the group we're owned by. And yeah, hopefully we can move on and expand this experiment to the entire company. I remember that, yeah, I think last month, there's an ex-Zaha folk, I think Cristiano, all the others are not here anymore, but there's this guy called Michel Grau, who was at Zaha 10 years ago. He then moved to Perma-Stiliza. He was part of the Perma-Stiliza moving forward, setting up team, which was basically Perma-Stiliza saying, we want to change the way we deliver facade. We need to move on to 3D, to the cloud, fully integrated environment. And yeah, he's not a Perma-Stiliza anymore. He was saying it was really hard for them to implement these new processes along the entire production line, especially the guy who actually is in front of the machine. He knows how metal works that you might not know. So yeah, what we were saying is that don't try to be too quick at doing all these changes. So that's why, yeah, I will try to say this should be the way, but we're not gonna move every single person, every single project on that workflow. It just needs to have a little bit of time for people to adapt. And yeah, let's see what happens.
So as a contractor, you have a really strong footprint in the manufacturing, and of course, you've been talking about this vision that we've been looking forward to in construction for some time, which is going to a paperless office and paperless construction, which would be a blessing. Right now, when we reach for information, we look for that information in paper, and that's been the legacy as long as I've been alive. What do you think is going to take for the building industry to start using the model as a central source of information and reach for the digital equivalent and stop reaching for paper? What do you think needs to happen for that process to be implemented?
Thank you. Well, I think I was lucky enough to be part of a team who set up already 10 years ago an approval process on top of the 3D model that that was on the Louis Vuitton Foundation project from Gehry in Paris. We set up a platform that was, at the end, more than 100 users. In the beginning, everybody was so reluctant to build in or to model in 3D. They were like, oh yeah, 40 years I've been doing stadiums and all of it, all my life. I don't need 3D, like 2D is fine. So it took a little bit of time to convince the people. Obviously, the project geometry is a little tricky, so it needed a little bit more sophisticated workflow. So that was a special project, obviously. So that increased a little bit the scaling up to 3D. We did 3D approvals until a certain level of details. But when you go towards level of detail like waterproofing, there was always 2D PDFs joined to it, that you click on it, and then, because if you go to that level of detail, as an architect on the building process, you're just never going to finish modeling. So I think it will always be a little bit of a hybrid approach that should be considered. But to try to move that for the entire industry, I don't know. I think it's just always about a little bit of going through cultural barriers, law, legislation barriers. And yeah, you might need a generation or half a generation, or maybe less, hopefully, that we can say finally we can deliver entirely in 3D. Yeah, patience. What's that? I think it's a lot, yeah. Yeah, definitely. People, when I started Gehry 10 years ago, people would say, yeah, it's going to be quick. It's like 5 years, 4 years from now. So always, I like to say, we're still waiting for the Tesla effect, that I think I've heard about electric cars since I was born, but nobody so far was able to make them sexy. And yeah, it seems to me that Tesla appeared and made electric cars sexy, and now you have hybrid cars, electric cars, not everywhere, but it just went up quite quickly. So hopefully somebody can make BIM sexy.